Hi, beautiful people. So today we're talking about how the slopes of two lines help determine whether they're parallel or perpendicular. And this comes in our section on parallel and perpendicular lines. And so this is just relating to lines in the coordinate plane. So there are some theorems that we're going to start with, and that's the theorem of parallel lines and the theorem of perpendicular lines. All right, the theorem of parallel lines says that in the coordinate plane, two distinct lines are parallel if and only if the slopes are equal. So just a little note over here. The word distinct just means that they're not the same line. So they're not coincident lines. So different lines. Okay, so they won't have the same slope and y-intercept. They'll just have the same slope. So in layman's terms, basically this says that parallel lines have the same slope. Okay. And then I want to add a little bit of notation station really quick. Right here, it says if and only if. In the future, I might abbreviate if and only if to IFF or IFF or IFF like this. And that means if and only if. And I don't know why mathematicians decided to abbreviate it like that with two F's, but it means if and only if, okay? And if and only if is bidirectional, so that means if you have two distinct lines and they're parallel, then their slopes are equal. And also, if you have two distinct lines with equal slopes, then they're parallel. So you can go forward or backward with this rule. So slopes need to be the same. And then I've got the theorem of perpendicular lines. Okay, so the theorem of parallel lines is like pretty straightforward. They're the same or the slopes are equal. The theorem of perpendicular lines says that if in this coordinate plane, two distinct lines are perpendicular if and only if the slopes are opposite reciprocals. So some things to define here, opposite reciprocals. And you'll notice that I use that notation IFF for if and only if, just because I can write less things when I'm writing this definition. So opposite reciprocals, are basically like one is positive and one is negative, and they're inverses of each other. So like if I have 3/5, the opposite reciprocal is -5/3. Okay, so reciprocals, opposite reciprocals. We're going to do a few examples. Okay, so how about 2/3? The opposite reciprocal is -3/2. -5/8. The opposite reciprocal is 8/5. The number 7. The opposite reciprocal is -1/7. The number -2. The opposite reciprocal is 1/2. And -1/3. The opposite reciprocal is 3. Okay, so take a minute, look at these numbers and see what happens. So you'll notice that for each number, I change signs. So in this first example, this one is positive and this one is negative. In the second example, the first one is negative and the second one is positive. In the third example, the first one is positive and the second one is negative. In the fourth example, the first one is negative and the second one is positive. And in the last example, the first one's negative and the last one's positive. Okay, so we're flipping signs. That's what opposite means. And then reciprocal, you'll notice that the numerator and the denominator switch places. So 2 was in the numerator for that first one, and it became the denominator for its reciprocal. Okay, same thing here. 5 was in the numerator for the first one, and it became the denominator in its reciprocal. So not only do we have to flip the numbers over the fraction bar, but we have to change signs. And it's very important that you notice that when you have a whole number as the first number, it's actually 2/1, which is why its reciprocal becomes 1/2, or whatever the whole number is over 1. All right, that's it.